Hello students, today you are going to study principle of reversibility and lateral displacement. Statement: it states that the path of a ray of light is reversible. Let us better to understand taking the diagram. When light travels from air to water, see here, in a glass water is there and above the water there is a air. Now here air, its refractive index I am writing here N1, and water, its refractive index I am writing N2. Air is a rarer medium, water is denser medium. So this is incident ray. It incidents at the air water interface. So you know, when light travels from air to water, that means rarer to denser, it bends towards the normal, right? So if I keep a plane mirror perpendicular to the path of refracted ray, what happens? The ray undergoes reflection and it retraces the same path as it comes from air to water, right? So now in this, water is act as a first medium and air it act as a second medium. Now here light, it travels from denser medium to rarer medium. So this is angle of incidence and this is angle of refraction. So now from Snell's law we are writing is one more equation, that is refraction of light here. So see, equation 1 and equation 2 is multiplying equation 1 and equation 2. What we are getting? We are getting that equals to 1. So what it means? See, it means refractive index of second medium with respect to first medium is equal to reciprocal of refractive index of first medium with respect to second medium, and vice versa. We can take in reverse order also. Okay. So now next you are going to study refraction through a glass slab. When light passes through a glass slab, how, in what manner the refraction it takes place, that one you are going to study here. So this glass slab is surrounded with air. Air, its refractive index is N1, glass slab, its refractive index is N2. Okay. So now the light, it travels from rarer medium to denser medium. Yes, what happens here? It bends towards the normal. So at the first surface, refraction takes place here. Now this one, this refracted ray, it acts as a incident ray for second surface. Now here light, it travels from denser medium to rarer medium. Then what happens? It bends away from the normal. So this is incident ray and this is emergent ray. So now if there is no glass slab, what happens? A ray, incident ray, it does not changes its path. This dotted line, yes, it shows the direction of incident ray when there is no glass slab. Because of glass slab, what happens here? Yes, the incident ray changes its path. In what manner it changes? Yes, it is parallel to the incident ray. It shifts, yes, parallel to the incident ray. So this one we are saying here lateral shift, and the perpendicular distance between incident ray and emergent ray is called lateral displacement. Okay. So here this is angle of incidence and angle of refraction. This is angle of emergence. Here incident ray and emergent ray are parallel, so we can say angle of incidence is equal to angle of emergence. See, mathematically we are proving that refraction on the first surface. Yes, refraction on the first surface, apply Snell's law, we are getting equation 1. Similarly, on second surface, apply Snell's law, again we are getting equation 2. There we are applying principle of reversibility, that is what refractive index of second medium with respect to first medium is equal to reciprocal of refractive index of first medium with respect to second medium. So this is equation 2. Compare equation 1 and 2 here. Yes, when we are comparing equation 1 and 2, there we are getting angle of incidence is same as angle of emergence. When I is equal to E, we can say that incident ray and emergent ray are parallel. Next, see this lateral displacement. What happens when incident ray, thickness of the glass slab, when thickness of the glass slab increases, what happens? Yes, lateral displacement is also increases. So lateral displacement depends upon what factor? First one, thickness of the glass slab. Okay, so now next, if angle of incidence increases, then what happens? This lateral displacement is also increases. So lateral displacement depends upon angle of incidence also. Next, if I increase the refractive index of the glass slab, then what happens? The power of bending is also increases. If the power of bending increases, then lateral displacement is also increases. Next, the color of light or wavelength of light which is used here is, if the wavelength of light changes, then definitely refractive index changes. So if refractive index changes, then what happens? Lateral displacement is also changes. So what you learned is lateral displacement means what? The perpendicular distance between incident ray and emergent ray when light undergoes refraction through glass slab is called lateral displacement. Lateral displacement depends on what factors? First, thickness of glass slab. Yes, if thickness is more, lateral displacement is more. Second, angle of incidence. If angle of incidence is more, then lateral displacement is also more. Next, refractive index of medium. So you know that yes, if refractive index is more, then lateral displacement is also more. Next, wavelength of light which is used is lateral displacement is increases when wavelength of light decreases. Yes, you know that refractive index of light, refractive index of medium depends upon wavelength of light, right? That one you learned in the last videos. So see, now question time. For which color of light lateral displacement is maximum? Yes, refractive index is maximum for what color? Violet. So here, if the refractive index is more, then lateral displacement is more, no? So answer is violet. Next, for which color of light lateral displacement is minimum? In visible range, you know that violet color its wavelength is minimum, red color its wavelength is maximum. So here our answer is red color. So why? So answer, because wavelength of violet color is less and wavelength of red color is more. Okay, so in today's class this much. In next class, yes, you will see refraction of light through prism. Okay, wait for next video. Thank you.